Hi, this is Mr. Mac. This is a video on the Session 4 Notes Introduction to Statistics. Now, statistics is the practice of taking samples and polling people to figure out what a population thinks or does or has in their home, or an average or something like this. It's the practice of trying to say this is the way things are from just looking at a few people and seeing how it works in their particular lives. Sometimes it's called inferential statistics, because what we're doing is we're inferring something to a population from a sample. And I'm going to let you read this part about statistical thinking and what statistical science does and can do for you and so forth like that. And so if you need to pause for a moment, read through these, and then come back. All right. Hi, welcome back. Now, when we are trying to find things out, there are 5 different methods that we could use to collect data. We could take a sample survey, and that's this. Let me just get a pointer here. That's this first one here, a sample survey. And the idea of a sample survey is that we select from the population a subset, and we find out what their attributes are, and we attribute those then to the population. Now, it is important that if you're going to do a sample survey, that you not introduce bias in the people that you select. If you, for example, wanted to see who people would select for a city councilman, and there was a Republican councilman running against a Democratic councilman, and you surveyed only Republicans, then naturally a larger proportion of them would like the Republican councilman. So it's important that your survey not introduce bias, and that your sample be pretty much the same as the population. Now, you can also do an observational study. Now, in an observational study, you don't perform any experiments, you don't do anything to people, you just go out and look at historical information that's available, and you study what seems to be happening in those records from things that have already happened. Now, you can also do an experiment. Now, an experiment is where you have something that you think might help, and so you gather groups of people together or something like this, and to one group you give this thing that you think would help, and to the other group you don't do that, and then you see if after the experiment is over, the people that had the treatment that you thought would help were actually helped or not. So in an experiment, there are some people receive the treatment, some people don't. Okay. Now, experimental units received. If it is a human, they're called subjects. All right. Now, simulation. Simulation is where actually an experiment might be too dangerous, so you do some kind of a simulation. We'll get to that a little bit more in detail later. And then finally, you could take a census. Now, a census is actually looking at all the people in a particular group and finding out the information about them. Now, here are some examples. Let's go ahead and go through these and see if we can't decide which one would be the best choice for collecting data. Number 1, examining the effects of alcohol on the fetus of a pregnant woman. Well, it's probably generally determined or agreed that alcohol is probably not good for fetuses or fetuses. So it would probably be better to do an observational study looking at records and so forth like that than to actually perform an experiment. So this one would be an observational study. Is that, hold it, wait, is that right? Yeah, observational study. Observational study. Now, comparing the benefits of a weight loss supplement to regular exercise, this would probably be best found out through an experiment. Determining the best strategy for landing an airplane in a storm. Well, you don't want to try this a couple of times and find out, oh, this is not a good way. So we would probably use a simulation for this one. Evaluating the effectiveness of early childhood intervention programs on college preparation or preparedness. This one, this data has probably been kept, so it would be a good idea to use a census on this one to just look at all of the programs that we have developed over the last, I don't know, however many years, and how well they did in getting students, prepared for college. Determining the average amount of time a student at Southern spends on homework compared to playing video games. Probably a survey on this one, but you'd have to make sure that you didn't maybe collect this information as the students were coming out of the computer lab. Evaluating the impact of lack of sleep on driving ability. Again here, probably an observational study. Or a simulation. Maybe even simulation would be better on this one, because it would be dangerous to actually perform an experiment, and I'm not so sure that there are records that you could study. So perhaps you could give somebody, do lack of sleep, but just have them simulate driving rather than taking them out and having them actually operate a vehicle. Now, it turns out that we want to know these things about the population, but it's many times prohibitive or inconvenient to survey the entire population, so we ordinarily take a sample. Okay, now examples. Determine for each sample if the data is collected from a population or a sample. In the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them own at least one pet. This would, of course, be a sample. The college degrees of every employee in the hospital. This would be a population. Well, the population of the hospital, at least. C, to estimate the gas mileage of new cars sold in the United States, the Consumer Advocacy Group tests 845 new cars and finds they have an average of 25.1 miles per gallon. This would be a sample. There's certainly more than 845 new cars. And number 2, identify the population and the sample. Describe the sample. In the United States, a survey of 1,000 households with at least one child found that 874 of them have at least 2 computers. Okay, now the population would be U.S. citizens or U.S. households with one child. And the survey, or the sample, would be these 1,000 households. B, in a university, a survey of 1,641 students found that 479 of them do not know the name of their college's mascot. Okay, now the population would be the students at the university, and the sample would be these 1,641 of them. Sample data must be collected correctly, randomly, in order to draw conclusions about the population. If collected correctly, most of the time our sample should possess the same or similar characteristics as the sample population. If sample data are not collected in an appropriate way, the data could be useless or biased. This is a very, very bad word. If your sample is biased, then you're not going to get good results. Now, it is very important that when you're going to collect data, that you design the method of choosing your sample so that you don't introduce that bias. And that sometimes is not all that easy. There are all kinds of different biases that will show up, or there are reasons why sampling is not easy. You'll find that if you're sampling about a particular issue, people that have strong feelings about the issue will respond more than those that really don't care about it much. And so that would give you a voluntary response bias. Now also, if your sample is such that you say, well, I'll just put these papers out here on the table in the library, and as people go out, they can pick one up and fill it out and hand it in. A lot of times, a certain type of individual will respond to those samples, and so you'd have perhaps a convenience bias. Sometimes there are different segments of the population, and one segment of the population will be not covered or represented as well in the sample as the others, and that would be under coverage bias. And now also, a lot of times people have trouble with their samples because people that are selected to be sampled choose not to respond. Sometimes also the survey itself will have questions in a certain way that will cause people to respond the way the reviewer wants rather than to respond honestly, and that would be response bias. And sometimes people will be a little confused because they won't quite understand the questions, and so they might be saying one thing when they actually believe the opposite, and that would be a wording effect type of bias. Now we've got some examples here. Describe the bias in each of the following situations. There may be more than one answer in some cases. A principal selects a group of students for her principal's advisory committee and asks students to share their opinions about her performance as a principal. Well, let's see here. First of all, it doesn't say how this group advisory committee was selected, but most likely the advisory committee was selected of people who were doing well at school, and they were the movers and shakers, and so perhaps there would be an undercoverage bias, and the group of students that are not doing well in school would be underrepresented. I think that'd probably be the best answer to that one. Number 8, a sample survey question asks, would you be more or less likely to go on a date with someone you met on an online dating site or blind date arranged by a friend? Answer, yes or no. Sample, let's see, they don't tell how it was, they don't say how it was collected. I'm not sure which one this would be. It doesn't seem like a very good way to select a sample, but I think we would need to know more about who was asked the question and how they were asked the question and so forth like this. Maybe one of them up here, I don't really know. We probably need to ask Ms. Weaver on that one. Number 9, a radio DJ asks listeners to call in or text the response to the following question. Should parents be allowed to keep their kids home from school even if they aren't sick? Okay, well now, here we've got a usually if it's a radio show, there will be an audience of a certain type, and so they would the sample wouldn't be well random because a lot of these people would have similar beliefs to what the DJ is saying, so that would be bias, but what would it be? Maybe convenience, because I mean they just broadcast this out there and it's convenient for the sampler, but it's probably not a random sample. The student government advisor is interested in arranging several competitions for an upcoming pep rally. She wanted to know which games students at her school would like to have at the event. So she asked students in her A-day classes. Well, if her students are in A-day classes, they are all IB students, and that might be different. That again is not a good random sample. So there's probably a bias already in those particular students. 11, a computer company is interested in customer opinions about its new software products. So it sends a questionnaire to 5,000 customers to register their product after purchase. 1,250 customers returned the survey. This might be response bias or non-response bias. When people who have been chosen refuse to respond, and there's a lot that didn't respond, and then also the people that did respond probably, voluntary response. When the people choose to be part of a sample, they tend to have very strong opinions, usually negative. So most likely the people that responded to the survey might have had some opinion, and I think there's probably a pretty good chance that some of their responses would be negative. Okay, so we've talked about sampling a little bit and bias. I'm going to stop this particular video and then start another one.